to better understand, I guess, what's going on, some of the inner workings of a air-bearing head. I have a frame. This is a Mark 10 frame, and it's all torn down, and so maybe this will better illustrate or help you to understand just exactly what goes on with an air bearing and how that's achieved. So this would be the bottom side of the head assembly as it would bolt into a transport. And so here we would have the air inlet, and if you notice on the assembled one here, we have a little disc here, and that's a filter with a little hole in it. That mates up with the little rubber air nipple that's on the transport when you bolt this down. And so there's your air inlet, and inside here we have a little filter. So we have an O-ring down in the bottom, and then we have a little filter element that'll trap any minute solid particles that may be in the air supply. And then you have another O-ring on top of that, and of course this would then mount in this little cavity here with the Allen screws. Now, two of these are recessed, so when this is bolted in, they mount flat or flush with the surface, and this one over here is not countersunk or recessed. It's a head of this screw is above the surface. And the reason that was done that way is on the transport there's a plunger that this presses against, and behind that plunger on the back side there's a little micro switch. And what that tells the transport and the VTR is that this is a air bearing head, and it activates the air pressure sensing circuits. You know, if your air pressure drops below a certain PSI, then the machine won't allow you to turn the head on. Well, that's what that activates, is when this little screw head presses that plunger and activates the air switch, the electrical switch. It activates the error circuitry for the air pressure. Now, if you were mounting a non-air bearing head, or what's known as a ball bearing head, then you would just have a hole here. You wouldn't have the filter, and you wouldn't have that screw to press the plunger in. So the machine, its air testing circuit will not be enabled for a ball bearing head. Okay, so the air comes in through the filter, and through the filter there's a little hole and there's a channel that is goes from here over to this little channel here. And if you notice on the back of the casting, there's a little Allen set screw that is screwed in there to fill that hole in. And what that is, you know, that was done during manufacturing. And they drilled that channel to get the air from here to here. This has been filled up with potting material, butyrate, you know, that dries hard. And so what you have here is another channel, and from this channel you have a little pipe that comes off of this side, and it's epoxied in to a hole in the casting here. And likewise you have a hole here, which is down in the channel, which has been covered up. You can't see it now. And that brings the air up here to this hole, and then up here to this hole in the casting. And that's where the motor is mounted. And here we have a motor. It's kind of rusty, but this is the mounting screws, which line up with these holes, and that allows you to mount the motor to the frame casting. And then here you have a hole, and then here you have a hole. And those holes line up with the air supply holes in the casting when this thing is all mounted. So that gets the air into this bearing journal and into this bearing journal, which is the back and the front end of the motor. Looking at these air bearings, they look like they're just solid pieces of brass, which they are for the most part, but there are a series of tiny holes drilled into this block of brass that connect to this supply hole on each end. And if you were looking at it on a drawing, it would look, the airflow would look very similar to that. The air hole arrangement and the airflow. And so what that allows is you know, for the air to be distributed evenly around the circumference of the motor shaft. And if you'll look here, you see this bearing is about 1 inch deep, and that corresponds to this part of the shaft. And on the back end you have the same thing again, about 1 inch deep bearing, and that corresponds to this end of the shaft. This part of the shaft is the permanent magnet part, and it is situated over the pole pieces in the motor. So, you know, it would look something like that internally, the alignment. So when the air is applied and it comes out all the little holes around the circumference, it's being forced out between the gap between the bearing and the shaft itself, and it escapes over these flat surfaces. And so on the other end we would have the head drum. Now these are all very close tolerances, so you know, that has to be kept very clean, and no grit can be allowed to enter in there. And you know, it would be very bad if you got grit in your air supply and it became lodged. It would score the surfaces, and of course it wouldn't take much, you know, to ruin the highly polished and flat surfaces of the air bearings. So that's basically what goes on inside the motor itself, you know, with the air and so therefore it has to be very, very clean and very flat, and you know, and highly polished, very slick and like a mirror. And so to test the validity of all of the lapping work, we'll take this head that's a working head, that's just minus its shaft and drum, and we'll assemble the drum that we want to test out onto this motor and bolt it on a machine, and we'll put some air on it and spin it up to speed and see what we got.